Final question, and a really tough one. We've got a container for salt, which is a cylinder on top of a cone. The cylinder has a radius of 3 meters and a height of h meters, which we can see from the diagram. And the cone has a base radius of 3 meters, the same as the cylinder above it, and a vertical height of 4 meters. The container is empty, and it's then filled with salt at a constant rate. And it's important that it's at a constant rate it's filled at. After 5 hours, the depth of the salt is 6 meters above the vertex of the cone. This is the vertex of the cone. So after 5 hours, this 4 meters is filled up here and another 2 meters of the cylinder. And we're told that after 9 hours, the container's full. So we've got to work out the value of h, which is the height of the cylinder here. And the first thing we're going to do is work out the volume of the shape, which was filled in those first 5 hours. Now, in those first 5 hours, the cone is totally filled. So we need to work out the volume of the cone. And we also know 2 meters of the cylinder was filled as well. So we need to work out that volume of the cylinder, which was filled in that time as well. So volume of a cone, we're given the formula for here. It's a third times pi times the radius squared times the height. And that comes out to 12 pi. And we'll leave it in this form for now because it's much easier to work with it like that rather than a nasty decimal. To work out the volume of a cylinder, now we're not told the formula for that, but volume of a cylinder, we take the cross section, which is the area of the circle, and we multiply it by the height. So the volume of the cylinder filled, it was 2 meters of it was filled. The radius was 3. So the volume filled in 5 hours is 12 pi plus 18 pi, which is 30 pi, and that's meters cubed. So we can use this to work out the volume filled in 1 hour, which is just going to be 30 divided by 5. So that's 6 pi meters cubed in 1 hour. So from 5 hours when it's partly filled up to 9 hours, we've got another 4 hours. So that's 24 pi meters cubed were filled in that time. And we're going to use that to find out the height of the cylinder. Remember, that's what the questions are asking us for here. There's a couple of different ways we could go about this last step, but I think if we set out a formula, so we know that 24 pi meters cubed was filled, and that's equal to the remaining volume of the cylinder. Now, our formula for the volume of a cylinder is pi times the radius squared, so the radius cylinder is 3 squared, times the height. Now, the height we've got left here is our given height h, take away those 2 meters, which we know were filled up here. We can then tidy this up. If we divide both sides by pi, divide both sides by 9, we get that 24 over 9 is equal to the height, take away those 2 meters. We're almost there, but I'm just running out of space, so I've jumped over to the left here. So we want to find the value of h, and we've got to show that in its simplest form. So with our equation here, if we add 2 to both sides, we've got a value for h, but it's not a fraction in its simplest form. So let's change our 2 into a fraction with the same denominator. When we add those together, remember with common denominators, we keep that the same. We just add the numerators, and then that simplifies, dividing top and bottom by 3 to 14 over 3. and that's the final value you need.